Okay, guys, so here is the second half of the stoichiometry notes. We're going to go over the backside and shouldn't be as long as our first video. So go ahead and get started. The next topic we're going to cover is percent yield. Percent yield um, is a quantity, or it's a percentage that scientists use to measure the successfulness of their reactions or the recovering of products in their reactions. Okay. First few steps that a scientist has to do in order to calculate percent yield, they have to calculate their theoretical yield. Okay. The theoretical yield is, I'm sorry, let me get my pen real quick. There we go. So the theoretical yield is the mass of a product, the mass of the product that is calculated based on stoichiometric calculations. Okay, that is calculated based on stoichiometric calculations. All right, calculations. Okay, so they do the calculation of figuring out how much product that they could potentially receive in a reaction, and they use that as a starting point for their yield. Okay, actual yield or experimental yield is what they receive in an actual reaction. It's the product that they make. Okay, so this is the mass of the product that's a U, of the product obtained during a laboratory experiment. All right, laboratory experimento. All right. So we use both the actual yield and theoretical yield to calculate a percent yield. And this is simply a ratio between the actual yield and theoretical yield. Okay. All right. So in our formula, the formula that we'll have to be using is the actual yield divided by our theoretical yield and we multiply that by a percentage, which is 100%. Okay, and then when we do this, our final answer will always be in a percentage. Okay, and here's a simple note that you should have. The actual yield will always be lower than the theoretical yield. Okay, the closer your percent is to 100%, the more sorry about that, successful, the more successful your reaction was. Okay, so the closer your yield is to 100%, it's considered that your reaction was more successful. All right, so let's do a practice problem regarding percent yield. Okay, so it's a similar problem. You have 158 grams of aluminum hydroxide, and after the reaction, you measured that 48.2 grams of water were actually produced. So you did the calculation and you saw that you had 48.2 grams of water, which is one of your products. So it was a product This is your actual yield. This is what you physically received after the reaction. Okay? Your theoretical yield is something that we did earlier. Okay? That was 54.9 grams. Okay? So when we calculate the actual percent yield, we have to take our actual yield. So we take our 48.2 and we divide it by our theoretical yield, 54.9, and we multiply all that by 100. And once we do that, we get a percentage of 80. Whoa, that's a bad 8. We get 80. Oh my gosh. My apologies, guys. 88%. Okay. That's it for percent yield. We have to get our actual yield and our theoretical yield, and we put it in a fraction, and we do the math. Okay. So this says that we recovered 88% of our product based off of our theoretical yield. Okay. So that's what a percent yield tells us. It's telling us what we were able to recover based off of what our theoretical yield was. Okay. So I'm going to end it with discussing the limiting reactant and the excess reactants, and then we'll go over the example in class as together. Okay. So the limiting reactant limits the actual reaction. Okay, and that is because it is the first to run out in our reaction. Okay, limiting reactant is always the first one that runs out in our reaction. Our reaction is going to stop because that reactant is depleted. There is no more of it. Okay, kind of like that marker demo that I showed you in class. How reactants, they all each required one marker until one chemical ran out of the marker. That was our limiting reactant. Okay. Then what's left over, the reactant that is left over, they're referred to as excess. That means that we have too much of it. And they are left over because there is not enough. There's not enough of the other reactant in order for it to react. Okay, so they are left over since there is not enough of another reactant to react with. Okay, so that is the limiting reactant and the excess reactant. Okay, so that is it for these notes, guys. We will meet soon and we will go over the example that is located on the or the last portion of our stoichiometry notes. Alrighty. Thank you, and please continue studying.